Altair HyperWorks is an easy-to-learn tool to empower users to build high-fidelity, multidisciplinary models more easily. It gives users access to workflows that leverage domain knowledge across industries to enable users to complete complex tasks more efficiently and increase team productivity by allowing users to not only create designs, but to explore and optimize them digitally. HyperWorks focuses on faster product development by integrating tools that are required for today's product lifecycles. This includes connection to PDM systems, as well as integrated tools to manage multiple model variants and subsystems using a single model approach to streamline the process. Through this integration, Altair strives to match the complexity and connectivity of products with high-fidelity modeling tools that also provide a multidisciplinary, multi-physics, and multi-model simulation environment. And finally, HyperWorks is a unified CE environment for product development built on the foundations of HyperMesh, which is the most trusted standard for finite element modeling and visualization. This video series will explore Altair HyperWorks in detail to introduce users to the platform and explore how HyperWorks can give new and existing users access to a truly powerful simulation environment. This session will focus on the model visualization and interrogation in HyperWorks. But first, what we'll explore is how we can take advantage of more physics more easily with a unified platform and what this means, how we can leverage existing data, and then we'll dive into the tool and explore process-oriented workflows, intuitive tool layouts, how we can interrogate the model quickly, and then finally, the flexible selection methods available to users. Firstly, a little bit more about the platform. HyperWorks is designed not only to reduce the learning curve for new users, but also to make sure that there's a consistent look and feel across the product portfolio. This means that users can easily transfer learning from HyperWorks to our other pre-processing tools, such as Inspire and SimLab, but also carry across the learning to system modeling tools, CAD tools, math tools, and many, many more. Users can access all of these products using our unique licensing model, so reducing the burden of learning all of these tools is vitally important. We also recognize that there's many stakeholders across a business, so being able to interact easily with this platform is really important. Therefore, Altair is open and adaptable, so users can import data from existing CAD and also CE systems, and that can leverage technology that's already used by the business. And we can also allow users to export in those formats, so we can integrate Altair's tools into existing workflows as required. And that further embeds the tools. And we can do this through customization of our existing tools to help complement the workflows even further. Now let's get to know a little bit more about the HyperWorks user interface. So we'll explore some of the powerful modeling and visualization tools, and these include process-oriented workflows, intuitive tools, the ability to interrogate models quickly, and also flexible selection methods. We'll start by a quick overview of the user interface. The main user interface is broken up into several areas. Firstly, we have the title bar. This gives you access to common operations like open, save, export, convert. And then we have the ribbons. The ribbons give users access to all of the application commands, and these are grouped into logical sections. So all of the element commands are located on the elements ribbon, and the same is true for mesh and geometry and so on. This means the users can quickly find the tool they need using a sensible grouping in the ribbons. HyperWorks also gives users access to several different tools in the one user interface. So at the moment we're using HyperMesh, but in the top right of the screen we can create multiple windows, and those windows can have different tools or clients. These might be Motion View for building multi-body models, or some of our post-processing tools such as HyperGraph and HyperView These can be easily added to, renamed, and the sorting and display of the windows can also be changed really easily. On the left of the screen, we have browsers. So browsers allow for a more detailed view of the model. So this contains like an overall view of the model, but really gives dedicated views for certain processes and workflows. So the model browser gives detailed information about the model contents. The solver browser gives us detailed information about solver specific setup. And I have the mesh control browser open, which gives us detailed control of all of our mesh settings. Many workflows in HyperWorks take advantage of browsers to help manage the models more efficiently. At the bottom of the window, we have view controls. So this lets us set how the model is displayed. We can set things like cameras, mesh and geometry visualization, section views, the view lock, and we can control how the model is displayed and colored. By default, HyperWorks will do all of this for us automatically, but the user has the control they need. And then finally, we have the graphics area, where we can interact with the model, rotate, select, and interact with the model. And this helps us supply selections to all of the application commands and also visualize the model and interact with it in an efficient way. Let's take a little bit more of a detailed look at the ribbons. So as we mentioned, they're grouped into logical sections. But in addition to this, they're also subgrouped in the ribbon itself. So the geometry ribbon has all of the geometry tools grouped by creation methods, editing methods, and also cleanup methods. So anyone needing to create geometry can go to the creation region and knows that these are the tools for the job. In addition to that, there's a general focus on a left to right workflow. This means that users entering a ribbon who've maybe never used a specific workflow before start at the left and work their way along the ribbon to generate and interact with a workflow. So in this case, we can start by drawing shapes, creating those surfaces, dragging those surfaces into solids, and then doing any additional splitting as required. And this is carried across all the ribbons. So on the morphing ribbon, if users never used morphing before, they know to start on the left to define the setup. We then interact with the morphing tools, and then finally take that morphed shape, save them, and potentially rebuild the mesh if required as well. There's also very specific ribbons for individual workflows related to industries. So for example, we have an airbag solutions ribbon where users can create, fold, and house airbags in a consistent workflow. And we can also create our own custom ribbons as well. So I can create a ribbon, add all of the common tools, create my own workflows based on the order of those tools, and share that across the business. Now let's look at the commands. So in addition to the general tool grouping, some of the tools are further subdivided, and this ensures that the ribbons aren't overwhelmed with lots of different tools and the user's not sure which tools do what. In our case, we'll just isolate some components, and we'll enter the elements ribbon to edit the elements. Now, editing elements consists of many different operations, and therefore we have a sub-ribbon which breaks out the edit elements functionality into logical tools. So I'll select the Move tool, and each tool has its own context menu where we supply a user selection, and again we follow it along left to right. So the Move tool lets us find holes we can move, or let us interact with the model directly. For users that have never used the tool before, there's additional help which can be accessed directly in the tool, and also some help videos to show how the intended use of the tool should be. This carries across all of the tools. So if we wanted to create some elements, we get our own interaction context menu, we have additional help, and a video to show us how to interact with the tool. So it's really easy to start with new tools interact with them, or simply refresh your memory on some other functionality. And this is carried across to other tools. So where necessary, such as the mid-surface tool, we break this down into logical sub-ribbons where we can interact with the tools in a more logical way, and the user isn't overwhelmed with lots of different inputs and we're not sure which one we need for a particular action. So these intuitive tools make it possible to pick up new tools easily with a consistent tool layout and the in-app help to help with the learning. Next up, let's have a look at the browsers in more detail. So as I mentioned before, browsers are where we come to get a more detailed view of the model. The top level view of the model can be found in the model browser, and this gives us a load of information about everything we've defined in our model. For example, we can see that we have 167 materials, and expanding this out further lets us break this down into logically grouped items again. So I can see how many elastic materials, if we've got elastoplastic materials, what formulation they are, and so on. And each of these browsers can be drilled down into just using a double click. And this opens our material specific browser where we get even more information that's required. So I can quickly just sort our columns and get all the information we need straight up front. Selecting any of these items gives us an entity editor where I can make direct edits to the material settings for individual items or for multiple selections. Browsers also contain a search bar where the user can additionally filter these items to make it a little bit easier to find what we're looking for. For example, let's build a material filter. So I'll enter the search tool, and straight away we've got our previous searches, which it's saved, or we can build our own. And this has an automatically intelligent filter. So I can see all of the items I can filter on. I'll start with type. And once I've selected that, it will give me the next options. So I can have equals, contains, in a list, not in a list, and so on. And again, once I've hit equals, it gives me the options that are in this particular model. So I want to find all elastoplastic materials and hit enter. You'll see it's now filtered by type, and we can see that because we have a little filter funnel next to the type column. I can then append additional search criteria. So for example, I might also be looking for materials with a specific ID. And again, we can put less than equals to, and type in a value. So in a couple of clicks, I can filter all of my information down, and inside of the browser, I can actually isolate those components. So any component with that material assigned is visualized in our model. And this is consistent across all the browsers. So in my component browser, for example, I can interact with the same filters. So this time I'll filter maybe by name, and I'll ask it to contain a specific word key, maybe rear. And I'll make sure that it's not in a specific include. So I'll say the include isn't include 37. And then finally, we might know what the material ID is. So I can say material ID is greater than our other filter. Okay. So that's all of our components with rear in the name, not in the include that I've requested, and with a material ID greater than that ID. And we can isolate those graphically. So using the browser view, we can really quickly navigate, filter, and interrogate the model and make changes on individual items or multiple items in one go. Next, we'll take a look at the view controls at the bottom of the window. So far I've been using the camera view, and this is a way of saving certain views. So I'll change to the frame view of the model. And obviously when we're working with large models, it's important that we might want to focus on specific regions. So we have this lock option. What lock view does is locks and creates a temporary view so that I'm only interacting from now on with what's on the screen, so the frame of the model. So any show all commands, isolate commands will be honoring the saved view. So I'm not going to get a load of components appearing that I don't want to interact with. We can graphically interact with the model, select and use shortcuts to hide items, or using right click. And all of the shortcuts are listed for the user. Or we can enter the hide show tool directly from the view controls at the bottom. And this gives us the opportunity to just graphically select the bodies that we want to hide, do things like reverse selection, isolate, hide all, show all, and so on. Moving along the ribbon, we also have the ability to control the mesh and geometry visualization. So I've got both in this model. So I can quickly change the geometry style to things like wireframe, transparent, solid, or completely disable it. And I can do the same with the mesh. So I can change to no lines, lines, shaded, wireframe, and so on. And even completely disable the mesh display. So it makes it really easy to isolate geometry, isolate mesh, all in a single control at the bottom. We can then also turn on things like 3D beams, shell thicknesses, or even go down to the level of ply details. And we can turn on element handles and force text. We can also control how the model is colored. So at the moment we're coloring based on HyperWorks choice, which is component coloring. But we can change that. So we can disable automatic and actually ask it to color in a certain way. So let's ask it to color by material. And we get a material coloring list. By property, we get property coloring. And then we can color by thickness. Where it makes logical sense, the coloring mode can also have a legend on the right. And this can be interacted with by the user. So I'll toggle my geometry off just to leave us with mesh. And then I'll also change the legend to be ranged so I can see from 0.1 through to 5 the thickness on the model. And we can control the coloring style. We can use it to isolate certain element thicknesses. Or we can interact with the legend directly, typing in the element thickness we need, and it will isolate all of the other components. Let's do the same with element quality. And again, the legend on the right will tell us all of the elements that have failed the checks. So I have 53 elements that have failed, and all of the criteria that we're using to check the element quality. So we can see here the region around our model. We have some that fail the max size check and some that fail the Jacobian check. And again, each of these can be delved into. So I can look at the max size. I can get it to show me all the element sizes. Change the color style and also use maybe a double slider. So I can find elements in a certain range of sizes. So view controls are a really useful way to help the user control the visualization quickly and all in a single location at the bottom. What we've added to the view controls is also a section view. So if I toggle back to automatic, we can also add in and interact with a section cut directly on the model. So I have some saved, such as the vehicle Y cut, and a vertical cut as well. But I can easily add my own new ones, change the cutting direction, and drag this through the model. So it lets me take section cuts directly on the model. It will section geometry and mesh, and we can also control whether it's cropping the element edges or showing us the full elements that it's interacting with. These can be saved and stored as required. And lastly, I wanted to show the flexible selection methods in the tool. So interacting and selecting the model is vital for all of the commands. So any command I interact with in HyperWorks will typically want me to select something. And when we have large models or complex geometries, it's important that we have a lot of flexibility in how we select items. The way that we interact with the selection is through the selection filter in the top left of the modeling window. And this has a filter applied so that when I choose a certain item, the selection graphically honors that. So I'm in component selector. I can select a couple of components on the screen. It adds them to the selector, and then I can do something with them. In this case, we might want to isolate the items. And this carries down to other selection types as well. So if I go to the element selector, I'm now at the element level, and we get tooltips, so I can hover over items and it'll give me information relevant to that selector. So for example, the element number, the element type, and even things like the thickness of it. We can also do reference-based selections. So if I bring my frame back, I now want to select some items by material. So I'll change to my material selector. I want to select everything with this, maybe this purple material. You'll see I've selected one material in the list, but now I maybe want to know which components have that material assigned. So what I can do is just change to the component selector, and it will select the 73 components that have that material assigned. In this case, there's only 6 components from my chassis. Everything else is outside of my locked view, so it won't show those. We can then take that the next level, so I can take the component selectors, select 2 items, and maybe I want to select all of the elements. Again, changing to the selection type will automatically reference select the items I'm interested in, and I can again isolate them if required. And I can do that each way. So I can go from elements to components, components to material, and so on. So it's really easy to quickly reference select items that are required. For more advanced selections, we have the Advanced Selection tool, which is accessed using the spacebar. And again, this is sensitive to the context of the selector we're in. So I'm in the element selector, so I can do selections by component. I'll get the component list, and I can select it from this list, or I can select it graphically. But I can also do more entity-based selection types. So I might want to select by config. I might want to select all of my 3-node shells, and that adds them to my selector. And I can then do things like selecting adjacent, and these all have shortcuts. So I can select the adjacent layers around my trias, for example. I can also, in Advanced Selector, change to by edge and by face to pick based on the topology of the model. So I'll go to by edge, and very quickly we can select the edges that we want to select, and it will grab the associated elements. The Advanced Selector also lets us make selections not just to add to what we've already got, but also to subtract or intersect that selection as well. So let's start with the material selector. And again, I'll grab our purple material and change to the components. So I've got 73 components selected. But let's say I only want to select components in a certain include. In the Advanced Selector, I can change to an intersect, and it will combine the selection that I've got graphically, which is the 73 components, with components in the include that I select. So let's say we only want to pick those that exist in the frame, and you'll see that our selection goes from down to 6 components, and I can isolate those items again. So very quickly you can make these advanced selections really easily. And ultimately, the users can select what's required for all of the HyperWorks commands, tools, and workflows really quickly. So that brings us to the end of the model visualization and interrogation overview. Firstly, we discussed exploring more physics, so how we have a consistent user interface across multiple tools. So users that have picked up HyperWorks should find it easier to pick up some of our other tools, all available under the Altair units. HyperWorks leverages existing data by being open and adaptable, so we can import and export in several CAD and CAE formats to integrate into your workflow. And then we looked at the user interface. So we looked at how the process-oriented workflows make it easier to find items by the way that they're grouped. We looked at how we can interrogate the model quickly. We looked at the intuitive tools, how the built-in help and the intuitive left-to-right workflow makes it easy to pick up new workflows and tools. And then how the display styles and the flexible selection methods make it very easy to interact with the model and speed up the tasks that we need to perform.